Alright, buckle up history nerds and sci-fi fanatics. Because today, we are diving headfirst into the one concept that has dominated human imagination since the dawn of fiction, time travel. We're not just talking about cool movie plots, we're talking about the mind-bending physics, the impossible paradoxes, and the tiny possibility that maybe, just maybe, it could actually happen. Think about it. If you could go anywhere, when would you go? The Roaring Twenties, ancient Rome. Or maybe forward 500 years to see what incredible technology awaits. The appeal of time travel is simple. It's the ultimate cheat code for understanding existence. But here is the kicker: every physicist who seriously considers it runs straight into a brick wall of logic known as the grandfather paradox. You know the one: you travel back in time and accidentally stop your grandparents from meeting. Congratulations, you've just erased yourself from existence if you don't exist. How did you travel back in time to commit the paradoxical act? This paradox isn't just a fun philosophical game. It's a fundamental challenge to the idea that our universe allows for arbitrary changes to the past. If the past could be changed, causality breaks down entirely. It's why many physicists believe that if time travel is possible, it must be constrained in some way. Perhaps the universe has a self-correcting mechanism ensuring that certain events, like your grandparents' meeting, are unavoidable, or maybe. And this is where things get really weird. Traveling through time doesn't lead you back to your past, but to a slightly altered parallel reality. This idea of parallel universes solves the paradox neatly, but it also means you can never truly go home. So, setting aside the impossible movie logic for a moment, what does actual theoretical physics say about punching a hole in the space-time continuum? Well, the foundation of modern time travel theory rests entirely on Albert Einstein. As theories of special and general relativity, we often think of time as a constant, ticking forward relentlessly. Einstein proved that time actually relative to motion. The faster you move, the slower time passes for you relative to someone stationary. This is known as time dilation, and it is not theory, it is fact. GPS satellites have to account for it constantly, otherwise, their readings would be miles off. If you could accelerate yourself to a speed approaching the speed of light, time would effectively slow down dramatically for you. If you spent 5 years traveling at near light speed and then came back to Earth, you might find that 50 years had passed for everyone else. Congratulations! You just traveled 45 years into the future. This isn't just theoretical, it's mathematically sound. Future travel is technically possible, provided you have the energy and technology to achieve near light speeds. Unfortunately, moving backward in time is a much heavier lift, requiring us to confront the fabric of space-time itself. General relativity suggests that massive objects, like stars and black holes, warp the fabric of space-time. Much like a bowling ball placed on a stretched rubber sheet, the deeper the warp, the slower time runs. This is where the concept of the closed time-like curve, or CTC, comes in. If we could bend space-time enough to link a point in the future with a point in the past, we could create a stable loop, a natural time machine. How would we do this? The two main theoretical methods are wormholes and cosmic strings. Wormholes, often called Einstein-Rosen bridges, are hypothetical tunnels through space-time that could connect to distant locations, potentially even to different points in time. Imagine folding a piece of paper. A wormhole is the shortcut you create by stabbing a pencil through the fold. The only problem is that standard wormholes are incredibly unstable and would collapse instantly. To keep one open long enough for something to pass through, we would need exotic matter with negative mass or negative energy density. As far as we know, this stuff either doesn't exist or we can't harness it. The second exotic concept is the cosmic string. These are hypothetical, incredibly narrow, one-dimensional topological defects in the universe, believed to be relics from the early Big Bang. If you had to infinitely long cosmic strings, moving parallel to each other at incredibly high speeds, the immense gravitational field they generate could theoretically warp spacetime enough to create a CTC, a path that allows you to travel back to the past again. The energy requirements are insane, And we haven't even confirmed that cosmic strings exist, so while the math of general relativity doesn't explicitly forbid backward time travel, the practical requirements harnessing infinite energy, finding exotic matter, manipulating black holes make it seem pretty impossible right now. It seems the universe is very protective of causality. Whether you believe in the physics or the paradoxes, the discussion of time travel forces us to ask some profound questions about free will, destiny, and the nature of reality. Is history fixed? Can we change anything? And if we could travel through time, would we use it to fix mistakes or just to watch the dinosaurs? Tell me in the comments, if you had a working time machine right now, when and where is your first destination? Let me know. Thanks for watching. Please like and subscribe for more videos. Bye bye.